Okay, in example 4 of section 6.2, part 3, it gives us a graph, and it tells us to find the intercepts and indicate whether the graph is symmetric with the x-axis, the y-axis, the origin. Much easier to do, but we are reading information from a graph for the first time, so let's make sure we're all understanding what's going on. So I'm going to start with the intercepts because to me that's the easier process. So for example A, the picture shown is like this. This is a hyperbola. We won't graph these in our class, they're graphed in pre-calc. But we can pull information off of it. So the first thing we need are the x-intercepts. This is where the graph touches or crosses the x-axis. And we can see that it's crossing the x-axis at -1 and +1. So -1, 0, and 1, 0. The y-intercept is where the graph is crossing the y-axis. Well, this particular graph doesn't ever touch the y-axis. So there isn't one. We're going to say no. Now we're going to come in and talk about symmetry. So does it have symmetry to the x-axis? That means, does it fold across the x-axis? Is the x-axis the fold line? Well, yeah. If we fold the top down, it's going to fold right on top of itself. So it has symmetry to the x-axis. So I'm going to simply say yes. What about the y-axis? So the y-axis means left to right. Does it fold left to right? Well, yeah, this piece would fold on top of this piece. So that is also a yes. Finally, what about the origin? So will this fold across itself, double fold? So if I fold this over to this and then fold it down, does it fold on top of itself? Yes. So there's another picture that has all 3 types of symmetry. Isn't that pretty slick? I like that one. It's a pretty picture. Okay, what about B? Part B on that one is our friend the parabola again. So let's pick off its x-intercept. So it's got an x-intercept over here at -2. My picture is not as good as the one you have. And also again at +2 is where it's crossing the x-axis. What about the y-intercept? Well, the y-intercept is down here at -3. You can pull those directly from the picture. In terms of symmetry, does it have any symmetry to the x-axis? In other words, can I use the x-axis and fold it across and fold it onto itself? Well, no, because this little hump would fold up here like this. So this is a big no. What about the y-axis? That one would be a yes. When we fold it left to right, it does fold on top of itself. What about the origin? Well, no, because if I fold over and then fold up, this little piece right here would end up being up here, and that's not true. So, okay, hopefully the idea of symmetry is starting to make some sense in terms of the pictures. There's 2 more examples. Draw those on the board really quick. We have C, which looks something like this. You could work ahead while I'm writing them on the board so you can figure out what the intercepts are, and also if you write down any ideas of symmetry. Or you can wait for me to get caught up. So we will eventually graph things that look like B, C, and D. We just won't graph part A, but we will graph the rest of these. Okay, so this particular picture, let's see if we can find its x-intercept. Wait a minute. Is there an x-intercept? Is it ever touching this axis? This thing is going off. There's actually an asymptote sitting on top of this axis. There's a boundary line here that we're never going to touch. So it doesn't touch. It does not touch the x-axis. It keeps going out, getting closer and closer, but it never does not actually touch it. So there is no x-intercept. So we're going to say no. There is a y-intercept though, and that y-intercept is up there, +1. What about any symmetry? Can you fold this thing across the x-axis? No. Can you fold it across the y-axis? No. And finally, can you fold it across the origin? Also a no. This thing doesn't fold onto itself no matter what axis you fold it across. If you fold this over, it doesn't work. If you fold it down, it doesn't work. If you fold it over and up, it doesn't work. So absolutely no symmetry on that picture at all. And it doesn't have to be. Okay, what about D, the last one? So this one actually ends up having 3 x-intercepts. There's one here, there's one here, and there's one here. So it looks like the first one's over there at -2. We have another one at the origin, and then you have one more at +2. The y-intercept is also at the origin. So this is a word of caution. For some reason, a lot of people, when you write origin for the x-intercept, forget to write it as the y-intercept. But if it's crossing the x-axis of the origin, it's also crossing the y-axis of the origin. What about symmetry? It doesn't have any symmetry to the x-axis. Can you fold it top to bottom and have it fold on itself? No. What about the y-axis? Can you fold it left to right and have it fold onto itself? Well, no, because this thumb or mountain fold over here and it's not there. What about the origin? In other words, I'm suspicious, and the reason I'm suspicious is because I see a repeated intercept with the same number. Sure enough, if you fold this over and then flip it top to bottom, what is up here is going to end up right smack over here. So this hill becomes this trough. So it actually has symmetry to the origin. So here's an example that has no axis or no y-axis, but ends up having symmetry to the origin. Okay, the remaining examples are actually pretty quick examples, so we're going to go ahead and do them in this segment of the lecture. Okay, so example 5 asks us to draw a complete graph. So the ribbon graph has symmetry to the x-axis. So all we see is this. We have a point over here at -4, 0. We have another point up here at 0, 2. And finally, we have another point over here at 5, 3, 0, 2, -4, 0. Well, they're just asking us to complete the graph. So what that means is if I have the point 0, 2, I must also have the point 0, -2. Notice the positive 2 and -2. If I have the point 3, 5, then I must also have the point 5, -3, because we're talking about the x-axis. That means both positive y and negative y have to exist. So here's a positive y, here's a negative y. Here's the positive y, here's the negative y. And the picture looks like that. So pretty quick, takes a lot longer to explain it than it does to draw it. Example 6 says, given that the point 1, 2, 1, 2 is on the graph, sorry, I lost it, is on the graph of an equation that is symmetric with respect to the origin. To origin. 1, 2. They're asking me what other point is on the graph. Well, I have to be able to double fold this. So I would have to be able to fold it down and then fold it over. So that means that the point -1, -2 is also on the graph. So to answer the question, we know that this point must also be on the graph in order to have symmetry to the origin. Example 7 is springboarding or kind of the same idea. If the graph of the equation is symmetric with respect to the y-axis, so symmetry to the y-axis, and we know that an x-intercept is out here at 6. Out here, we have an x-intercept at 6, 0. They want to know, name another x-intercept. Well, because we're going to fold it across this axis, and that means fix it over here at -6. We have to have another x-intercept. So the answer to that question is -6, 0. Example 8 tells us that the graph of an equation is with respect to the x-axis and that 2 is a y-intercept. So we're up here at 0, 2. They want us to name another y-intercept. Well, if we're going to fold it across the x-axis top to bottom, then we have to have another intercept down here at 0, -2. So name another intercept, y-intercept at 0, -2. So those are nice, quick, easy ones at the end of the homework. And then finally, our last example for section 2.2. Example 9 asks us to draw a graph that contains 2 x-intercepts. At one, the graph crosses. At the other, the graph touches. So we need 2 x-intercepts. It doesn't matter where you draw them. I'm just going to put them here and here. We need to be able to cross at one and touch at the other one. So I'm going to come in and cross at one, so I cross, but I'm going to touch at this one, which means it has to stay on the same side. Now that is not the only picture that fits this description. There are lots of pictures, but the key is that we're going to cross at one and touch at the other, and we only have those 2 x-intercepts. So I could have touched at this one and bounced on it and crossed at the other one. They could have been on either side of the x-axis, both on the negative side. It's a variety of answers, but they're all going to look similar to this. So And that wraps up section 2.2. We do not do section 2.3. It's all about graphing lines, and we do assume that you already know how to graph lines. So we're going to omit that and head to section 2.4, graphing circles.